Imagine you are walking along a beautiful, sun-drenched beach on the Greek island of Crete. The waves are gently crashing, the Mediterranean breeze is blowing, and you are scanning the ground, maybe looking for a nice seashell to take home. Instead, you look down at a slab of hard, fossilized coastal rock, and you see something completely impossible: a footprint. In fact, not just one footprint, but a whole scattered trackway of them, pressed deep into the ancient stone. Now, finding a footprint on a beach isn't exactly breaking news. But what if I told you that the rock these prints are permanently baked into is over 6 million years old? Take a second to really let that number sink in. 6 million years. This is long before our own species, Homo sapiens, ever existed. It's long before the Neanderthals built their first fires. It is even millions of years before Lucy, the famous Australopithecus, who supposedly represented our earliest wobbly steps on two legs in the African dirt. According to every science textbook you and I ever read in school, human ancestors at this point in deep history were strictly confined to the African continent. They were still figuring out how to comfortably leave the dense forest canopies, moving around mostly on all fours, much like modern chimpanzees. Yet, here we have dozens of prints, boldly stamped into the mud, clearly showing a creature walking upright on 2 feet, strolling across a European island. This isn't a pitch for a science fiction movie. This is a very real, incredibly heavily debated archaeological anomaly, known as the Trachilos footprints. Found near the tiny coastal village of Trachilos, in western Crete, these mysterious impressions have thrown a massive, heavy wrench into the neat and orderly timeline of human evolution. Today, we are going to dive into the dirt to figure out exactly who, or what, left these bizarre prints behind. Were they left by an early human ancestor who somehow wandered into Europe millions of years before they were supposed to? Or is nature just playing a very elaborate, evolutionary trick on us? To really understand why these footprints are giving paleoanthropologists collective heartburn, we have to completely reset our map of the world. We need to rewind the clock to the late Miocene epoch, specifically to about 605 million years ago. If you could take a time machine back to Crete during this era, you wouldn't even need to pack your swimsuit. The Earth was a drastically different place. The continents were still grinding into their modern positions, and the environment of the Mediterranean was entirely alien to what we see today. The story of this discovery actually starts just like ours did, with a guy going for a walk on a beach. It was the year 2002, and a Polish paleontologist named Gerard Gierlinski was on a holiday in Crete. But like any good scientist on vacation, he couldn't just sit in a lawn chair and sip a drink. His eyes were glued to the ground. While inspecting some coastal sedimentary rocks, he noticed a series of strange, distinct depressions. They didn't look like random water erosion. They had a deliberate shape. They had a rounded heel, a distinct sole, and most shockingly, 5 toes grouped together at the front. Gierlinski snapped some photos, probably scratched his head for a good long while, and eventually went back home. It wasn't until nearly a decade later that he managed to pull together a team of international researchers to return to Crete, seriously excavate the site, and scan the prints in 3D. And when they finally dated the rock and published their findings, the scientific community practically short-circuited. So why the massive uproar? To understand the sheer panic this caused in anthropology departments around the world, I want you to kick off your shoes for a second, or just picture your own bare foot. Look at your big toe. Notice how it sits neatly in line with all your other toes, pointing straight ahead. That tiny anatomical detail is the ultimate hallmark of a creature born to walk on the ground. We call it a non-divergent big toe. It acts as a powerful lever, helping you push off the earth with every single step you take. Now, compare your foot to that of a modern chimpanzee or a gorilla. If you look at their feet, their big toe sticks way out to the side, almost exactly like a thumb on a hand. This is called a divergent big toe. It is absolutely brilliant for grabbing onto tree branches and climbing through thick canopies, but it is completely terrible for a long-distance stroll on flat ground. When a modern ape tries to walk upright, they have a clumsy, rolling, side-to-side gait because their foot simply isn't built to launch them forward efficiently. When researchers meticulously scanned the over 50 individual footprints trapped in the Cretan rock, They were looking closely for that ape-like thumb toe, but it wasn't there. The creature that walked across that ancient Mediterranean mudflat had a big toe positioned firmly in line with its other digits. It also had a distinct ball of the foot, another purely human-like trait that acts as a vital shock absorber. Furthermore, the prints completely lacked claw marks, which instantly ruled out any prehistoric bears or other large roaming mammals that might have just been passing through. The sole of the foot was proportionately shorter than ours, and the heel was a bit narrower, but the foundational blueprint was unmistakably hominin. That is the umbrella term for the specific evolutionary group that includes modern humans and all of our extinct, upright walking ancestors. But presenting this physical evidence to the scientific establishment was basically like trying to convince a master chef that pizza was actually invented in Antarctica. The pushback was immediate, and it was incredibly fierce. The research paper documenting the find was repeatedly rejected by top scientific journals for years before finally being published in 2017. Many prominent paleoanthropologists outright refused to accept what the data was showing them. Some critics argued that the prints were just weirdly shaped indentations made by weather, water, and sea salt, essentially a geological illusion, an ancient Rorschach test playing tricks on hopeful researchers. Others argued they belonged to some extinct, non-ape mammal that just happened to have bizarrely shaped feet. This deep reluctance to accept the Trachilos footprints wasn't just scientists being unnecessarily stubborn or petty. It was about protecting a heavily researched, deeply established narrative. For decades, the undisputed holy grail of human origins has been the continent of Africa. Every major groundbreaking fossil find, from the famous Laetoli footprints in Tanzania to the ancient skull of Toumai in Chad, pointed to East and South Africa as the exclusive, undisputed cradle of humanity. To accept that a bipedal hominin was casually leaving footprints on a European island over 6 million years ago meant ripping up the very first chapter of our history and starting from scratch. So, if it really was a two-legged ancestor walking around Europe millions of years before they were supposed to be there, who exactly made the tracks? There were no bones found at the Trachilos site, only those ghostly indentations left in the mud. But ironically, the prime suspect for this prehistoric mystery had already been found, and it had been sitting in a dusty museum drawer in Germany for decades, waiting for someone to finally pay attention. Let's unlock that museum drawer. Back in 1944, during the chaotic final years of the Second World War, occupying German forces were building a military bunker near Athens, Greece. While digging deep into the dirt, they unearthed a fragile, fossilized lower jawbone. It eventually made its way back to Germany, where it sat in storage for decades, mostly ignored. Paleontologists eventually named the creature Graecopithecus freibergi, affectionately nicknamed El Graeco. For a very long time, scientists just assumed it was another run-of-the-mill extinct ape that casually swung through the European forests millions of years ago, completely unrelated to us. But in 2017, the exact same year the Trachilos footprints were finally published, a team of researchers decided to take a second look. They ran El Graeco's ancient jaw through a high-tech micro-CT scanner. They weren't really looking at the overall shape of the jawbone itself, but rather something hidden deep inside the bone, the roots of the teeth. To understand why this tiny detail is a massive deal, think about pulling a weed out of your garden. If you pull up an ape's premolar tooth, the root generally splits into 2 or 3 distinct sprawling prongs, gripping the jawbone like a claw. But if you pull up a human tooth, or an early hominin tooth, those roots are tightly fused together into a single, thick, robust peg. It is a very specific, undisputed evolutionary calling card. When the researchers scanned El Graeco's teeth, they saw that the roots were partially fused. It wasn't a perfectly modern human tooth, but it was definitively on its way there. It was a distinctly hominin trait. And the absolute kicker? The geological layer of soil wrapping that jawbone dated back roughly 7.2 million years. Suddenly, the historical dots started connecting in a way that made traditional scientists deeply uncomfortable. We have a creature with pre-human teeth living in Greece 7.2 million years ago, and we have a creature with pre-human feet walking around a Greek island 6.05 million years ago. Could El Graeco be the mysterious author of the Trachilos footprints, or at the very least, a close evolutionary cousin? This incredible realization sparked one of the most fiery controversies in modern anthropology. A small, highly vocal group of scientists began arguing for a radical new idea. What if the evolutionary split between chimpanzees and humans didn't happen in the dense forests of Africa at all? What if the actual cradle of humanity was the Eastern Mediterranean? Imagine what that means for our story. We are so heavily accustomed to the epic narrative of early humans rising up from the African savanna, boldly walking tall as the climate drastically changed. But this new hypothesis suggests our earliest ancestors might have actually taken their very first wobbly upright steps under a European sun. Now, before we go rewriting every textbook on the planet, we have to acknowledge the elephant in the room. Trying to rigidly reconstruct an entire evolutionary family tree from one single jawbone and a set of footprints is incredibly risky. It's a lot like trying to guess the entire complex plot of a 3-hour movie by looking at just 2 random frames of film. But the physical evidence exists, etched into bone and stone, and we cannot simply ignore it just because it happens to be highly inconvenient for established theories. However, there is a massive, glaring logistical problem staring us right in the face that we haven't talked about yet. If you look at a map right now, Crete is an island. It is surrounded on all sides by the deep, blue waters of the Mediterranean Sea. 6 million years ago, early apes were entirely focused on surviving, foraging, and not getting eaten by giant prehistoric predators. They certainly were not building wooden rafts, and they absolutely were not swimming dozens of miles across the open ocean. So, if these prints truly belong to an ancient, upright walking ape from the European mainland, how in the world did it walk onto an island in the first place? To solve this geographical puzzle, we have to look at one of the most apocalyptic, mind-bending events in our planet's history. It is known to geologists as the Mycenaean salinity crisis. Right around the time these footprints were being pressed into the mud, the tectonic plate carrying the African continent was slowly, relentlessly smashing northward into the European plate. As these massive landmasses ground together, they effectively pinched off the Strait of Gibraltar, that narrow, vital channel of water that connects the Atlantic Ocean to the Mediterranean Sea. Without the Atlantic continuously feeding it, and sitting under the blazing heat of the prehistoric sun, the entire Mediterranean Sea simply evaporated. Yes, you heard that right. The sea completely dried up. Picture yourself standing on the southern edge of modern-day Greece, looking out not at sparkling blue water, but at a colossal, blindingly white desert of solid salt, dipping miles below normal sea level. It was an oven-like wasteland, a deep basin where the air pressure at the bottom would have actually been noticeably heavier to breathe. During this chaotic geological period, the island of Crete wasn't an island at all. It was just a high mountain peak jutting out of a massive dry valley. This extreme climate event created temporary, vast land bridges spanning across continents. Animals could freely wander between North Africa, Southern Europe, and the Middle East without ever getting their feet wet. That is exactly how our mystery creature could have literally just walked right up to what is now the coastal edge of Crete. They were simply crossing a shifting, drying landscape, desperately searching for food, fresh water, or a safe refuge. But this extreme environment also brings us to the climax of our scientific debate, and it introduces a fascinating alternate theory that is just as mind-blowing as the idea of human origins starting in Europe. What if the creature that left these tracks wasn't our direct ancestor at all? What if we are looking at a spectacular, bizarre case of parallel evolution? In biology, parallel, or convergent, evolution is when nature solves the exact same problem twice, in completely different species. Think about how birds and bats both evolved wings to fly, even though they aren't closely related, or how dolphins and sharks have almost identical torpedo-shaped bodies, despite one being a mammal and the other a fish. As the Mediterranean environment rapidly dried out, the lush, dense forests that apes relied on were dying, quickly replaced by open, harsh grasslands and salt flats. If a group of native European apes suddenly found themselves stranded in this unforgiving, treeless environment, they would be forced to adapt or die. Standing up on 2 legs would have been a brilliant evolutionary hack for survival. It makes you look much bigger to roaming predators. It frees up your hands to carry scarce, valuable food over long distances, and it exposes far less of your body to the scorching midday sun. So, it is entirely possible that an isolated, forgotten group of apes in Europe independently figured out how to walk upright, entirely on their own, completely separate from the apes doing the exact same thing down in Africa. Under this theory, the Trachilos footprints do not belong to our great-great-grandfather. Instead, they belong to an evolutionary dead end, a failed, desperate experiment by nature, an ancient cousin who adopted our signature, two-legged stride, to survive a dying world, only to ultimately go extinct, leaving nothing behind but a few ghostly footsteps on a beach. Whether that creature was a direct, distant grandparent of ours, or just an evolutionary echo fading into the abyss of deep time, those footprints force us to confront a very uncomfortable truth about how we view ourselves. For decades, we have been deeply comforted by that famous, iconic illustration you see on t-shirts and classroom walls, the March of Progress. You know the one. A knuckle-dragging ape on the left, slowly and neatly standing up taller and taller, in a perfectly straight line, until it becomes a modern human on the right. It is a wonderfully simple, reassuring story. It is also a complete myth. The reality of human evolution is not a straight, single-lane highway heading toward a predetermined finish line. It is a wildly overgrown, chaotic, and heavily tangled bush. Branches shoot off in bizarre directions. Different species overlap, share environments, and sometimes even interbreed. And many branches simply snap off and die out completely, erased by changing climates or fierce competition. The Trachilos footprints are a blaring, 6 million-year-old reminder that nature is messy, and our family tree is incredibly crowded with ghosts. We still do not have a perfect, undisputed answer for who walked across that Cretan mudflat. Perhaps the true cradle of humanity wasn't just a single valley in East Africa, but rather a vast, shifting geographical zone stretching all the way from southern Europe, across the Mediterranean basin, and down into the African continent. Science, after all, is not a static set of facts permanently carved into stone. It is a living, breathing detective story. Right now, there could be dozens of other fossilized tracks, ancient tools, or even completely intact skeletons buried under the olive groves of Greece, or beneath the shifting sands of the Sahara, just waiting to completely shatter whatever new theories we come up with today. So, the next time you go for a walk, whether you are strolling along a sandy beach, hiking through the woods, or just walking down your local concrete sidewalk, take a brief moment to look down. Think about the unimaginable depths of time beneath your shoes. We are only ever one accidental discovery, one vacationing scientist looking at the right rock at exactly the right time, away from having to rewrite the entire history of the human race. What do you think? Did our absolute earliest ancestors actually take their very first upright steps under a European sun, or are we just looking at a bizarre, desperate ape trying to survive the apocalypse of a dried-up sea? I want to hear your best theories down in the comments below. If you enjoyed wandering through the deep, mysterious past with me today, make sure to hit that like button, share this video with a fellow history nerd, and subscribe to the channel so you never miss out on our next deep dive into the ancient world. Keep asking questions, keep digging, and I will see you in the next one.